Sorry about the abrupt ending on the last video. We were solving for theta, the last part of our right triangle. We knew that the two acute angles 63 degrees and theta make 90 degrees. 90 degrees minus 63 makes 27, the missing angle. Now that we've solved for x, one missing side, y, the second missing side, and theta, the missing angle, we have solved this right triangle. Now that we've solved this example, we can move on to example 2. Example 2 looks just like this here. To solve this right triangle, first we need to inspect it to understand what we need to solve for. First I noticed x. X is the missing side. If I look at the right angle, I also notice x is the hypotenuse. Let's label that now. Also looking at the triangle, I notice I'm missing both acute angles, theta and z. So to solve this right triangle, we're going to have to solve for x, z, and theta. Let's solve for the missing side first. To solve for this missing side x, I'm going to use the Pythagorean theorem. We already know that one side is 35, another side the leg is 9. To find the third side, the Pythagorean theorem is the fastest, most direct way to find that side. A squared plus b squared equals c squared. What's always important to remember is that the hypotenuse has to be c. X, the hypotenuse, that is c. I'm going to call 9a, b is going to be 35. Plug them in, 9 squared plus 35 squared is going to equal x squared. Nine squared is 81, plus 35 squared is 1,225, equals x squared. Addition, 1,306 is equal to x squared. Now, to solve for x, we need to square root both sides of the equation. X is going to equal, let's use our calculator to find that. Square root 1,306. We get 36.138622. Let's round that to the nearest tenth for the sides. X is going to equal 36.1. X is equal to 36.1. We're doing a good job working towards solving our right triangle. We just found the last missing side. Now we're going to move on and solve for the missing angles. First, we need to pick which angle we're going to solve for first. We could solve for either theta or z first. It is up to you, it does not matter. I'm going to solve for theta first. I'm going to put an arc over theta so I know I've ID'd that angle. Now that we have ID'd the angle, I can use it to go all the way across my triangle to find the opposite side, which is going to be 9. We've already labeled x as the hypotenuse. That means 35 is the adjacent side. When we come to set up SOHCAHTOA, so we can pick which trig function to use, we can use any two sides that we want, since we now know all three. I'm going to pick to use the opposite side 9 because it was given to me. The adjacent side 35 because it was given to me. 36.1 is correct for x, but we had to round to 0.1. So it's not going to be as good of an answer if we use 35 and 9. 9 is the opposite. 35 is the adjacent. Hopefully you can see that it's going to be a tangent problem. We're going to set up and use our arctangent function, or inverse of tangent, to solve for theta. Set up our trig equation. The tangent of theta is equal to 9 over 35. We use our inverse. Theta is equal to the inverse of tangent of 9 over 35. Remember to keep 9 over 35 inside of the parentheses. That way we know, our calculator will know to work on it together. Time to use our calculator. Find the inverse tangent function. 9 divided by 35. Close our parenthesis. 14.4. Since we are solving for an angle, we are going to round to the nearest whole angle. Theta equals 14 degrees. Now that we've found one of the acute angles, it is really easy to find for the third angle Z. 90 degrees minus 14, 76. Z equals 76 degrees. Now that we've solved for the missing side X, we've solved for both missing angles Z and theta, we have solved this right triangle. Today on your homework assignment and your in-class assignment, this is what you're going to be doing. You're going to be solving for all of the missing parts of your right triangles. Good luck.